Start the recording. All right, let's get going. So chapter 2, hopefully a fairly easy chapter. Essentially, the chapter is about plotting lines and the equations of lines. That's all it's about. So first off, let's introduce what we plot on. We plot on what we sometimes call the xy plane or the coordinate plane. And hopefully you're somewhat familiar with this plane. And we plot points on this plane. Now, if I were to try and plot the point 5, 2, what point is that?
It's x and then y.
X is 5.
So your point is going to be on that. 5 is going to be on your x-axis.
So I count 5 units this way. 1, 2, 3, 4, 5.
And then you're going to go up 2.
And then up 2, and there's my point. So this is the point 5, 2. Notice that your x-coordinate tells you how far away you are from the y-axis. I'm 5 units away from the y-axis. I'm 2 units away from the x-axis. Right? All right, so here's a point. Let's see, I'm going to go back 3 and down 4. What's the coordinates of that point?
It's going to be -3, -4.
So I meant to line it up like this. So that is -4, -3, right? No. -3, -4. Good. Paying attention. -3, -4. It's 3 units to the left, 4 units down. So you always start right here. Your x-coordinate, or your first coordinate, tells you how many units to move to the right or the left. Positive means to the right, negative means to the left. And your right number tells you how far to move up or down. Positive means move up, negative moves down. Fairly intuitive, right? Now, if I give you an arbitrary point, I say, let's look at the point x1, comma, y1. Here's a point x1, comma, y1. What is that point? That is a point whose distance from here is x1, x1 there, and whose distance from here is y1. So this would be y1. So we'll use x1, comma, y1 for an arbitrary point, a point that we don't know the exact coordinates of it. But what do we do know? If it's x1, y1, it's x1 that way and y1 that way. So that's what we use for a generic point that we don't know the exact coordinates of. All right, so that's points, plotting points. Now you're used to an equation, something like y equals 2x. Now, what is it saying? It's saying y is a number that's always double whatever x is. So if x is 0, what is y? If x is, so here's x, here's y. If x is 0, what's y? What's double 0? We're going to need to put this on the drill sheet. What is 2 times 0?
0.
0. Anything times 0 is 0. Okay. 0. 0 is double 0. All right. What's double 1? Ah, there's our 2. What's double -1? -2. What's double 3?
6.
What's double -2?
-4.
-4. Wonderful. So, how many numbers can I plug in x and y that satisfy this equation? Here we found some. I can plug in 0, 0, 1, 2, -1, -2. How many numbers can I plug in? An infinite number. So let's try to get a sense of what these numbers look like, these pairs of numbers. So let's see. I'm going to plot each associated point. I'm going to plot all the points that satisfy this equation. So 0, 0 satisfied it, so I'm going to plot that point. Here's 0, 0, right? All right. 1, 2 satisfied the equation, so I'm going to go plot the line, the point 1, 2. That's 1 to the right, 2 up. Right there. All right. -1, -2 also satisfied it. So -1, -2, that's right there. 3, 6 satisfied it. So 1, 2, 3, 1, 2, 3, 4, 5, 6. That's somewhere up here. And -2, -4 satisfied it. So -2, -4 also satisfied it. Now, of course, we didn't pick all the numbers that satisfy it. We just picked some of the numbers that satisfy it. If we were to pick all the numbers that satisfy it, then it would start looking like this. And you notice that, yes, it gives us all the points on this line. So this line is the set of all points that satisfy that equation. You pick any point on this line, and its height is going to be twice as big as its distance that way. How high up the y is always going to be twice as big as however far over the point is that way, x. Right? So, this is how you plot a line. Now, really, how many points do you need to plot a line? You just need 2 points. If I say draw the line through that point, you say which line? There's an infinite number of lines I can draw through that point. I can draw a line that goes that way, that way, that way, whatever. But if I say draw the line that goes through those 2 points, now there's only one line I can draw that actually goes through those 2 points, if I'm being accurate enough. And this is the only line that goes through those 2 points. There is no other line. So once you know 2 points on the line, you can plot the line. You don't need to plot a bunch of points like I did. If I would have drawn my x, y's accurately, you just need 2 points to draw a line through 2 points. And that's going to be the line that satisfies this. Make sense? Yeah. So that's going from an equation to plotting the equation. Again, we'll do a bunch of examples of these. I'm just going to go through each section, and then we'll go back and go through it again doing example problems from the book. Okay, so next we have the concept of slope. Perfect. So you know that slope is equal to rise over run. So let's now get rid of this, and we're going to talk about if you're going to talk about the slope, you need to talk about the slope between 2 points, right? We need 2 points to talk about the slope. So let's say that we have some random line. I have no clue what the line is. Some random line, and we want to talk about slope. Now I know that the line goes through this point, which we're going to call x1, comma, y1. And it goes through this other point, which we're going to call x2, comma, y2. So we got a line, and we just know 2 points that the line goes through. That's all we need. Now our job is to calculate the slope. What is the slope? It's rise over run. It's how high up we go over how far over we go. And so, looking at this triangle right here, so this was a point x1, comma, y1. So the rise is this distance, and the run is this distance. Right? Okay, so let's look at the rise. What is this distance? The coordinate system here is completely arbitrary. So how high is it from x to here? How high is this? Don't count over here. How high is it? Look, if I told you that we're looking at the point, 2, 17, right? How high up would we plot that point? 17. What if we were looking at the point 2, 5? How high up would that be? Okay, so now we're looking at the point x2, y2. How high up is it? y2. Y sub 2, whatever that is. That's how high it is. By definition, that's what we mean. When I say the point 2, 5, I'm saying the point that's 5 units up and 2 units over. That's what we mean. When I talk about the point x2, y2, I'm talking about the point that's y2 units up and x2 units over. So this distance right here is y2. This distance right here is, this was meant to be a parallel line. This was meant to be parallel to the x-axis. This distance right here is, how high up is this point?
Oh, okay, so y1.
This point is the same high up as this point. How high up is this point? How high is it from here to here? y1. That's what y1 means. It's the point that's y1 up. So this distance right here is y1. So this distance right here is same thing. So from here to here, we have y1 gets us from here to here. That's y1, right? y2 gets us to here. What is this distance?
You have to subtract. So you do y2 minus y1.
Let's go through this intuitively. Let's say Dan is 4 meters from me, and my laptop is 1 meter from me. How far is it between Dan and my laptop? Dan is 4 meters from me. The laptop is 1 meter from me. How far away is Dan from the laptop?
3 meters.
3 meters. You did the total distance minus the distance between me and the laptop gives you the distance between Dan and the laptop. Same concept. Total distance minus this distance leaves you with this distance. So it's y2 minus y1 is this portion. This is y1. This whole thing is y2. So this portion is y2 minus y1. All right. Let's try this again. What is the distance from the y-axis to this point?
X2.
So this total distance is x2. What's the distance just to that point? So what is this distance?
X1.
The whole distance minus that portion leaves you this portion. x2 minus x1. So this is x2 minus x1. So the slope is the rise over the run. What's our rise? How much did we go up?
Y2 minus Y1.
Wonderful. Over the run. How much did we go over? x2 minus x1. And that's how you calculate the slope of any given line. If you know 2 points that the line goes through, you can then calculate its slope. Let's do this really quick. Coming up with equations off the top of my head might be kind of ugly, but hopefully it doesn't come out too ugly. So let's look at something like 2y minus 4x equals 6. I don't know, something. So there's our equation. This is going to be the equation of a line. What does this line look like? I have no idea yet. We got to play with it. So first off, 0 is always a nice number to plug in. When I plug in 0 for x, what do we get for y? If we plug in 0 for x, then we have 2y is equal to 6, or in other words, y is equal to 3. So if x is 0, y has to be 3. That's the only number y you can plug in to make this equation work. Okay, let's try x equal to 1. So then we get 2y minus 4 equals 6. Or in other words, y is equal to, add 4 to both sides, gives us 2y equals 10. Or y is equal to,
No.
all right, too many steps in one go. There we go. 2y is equal to 10, so y is equal to 5. Right? So 0, 3, 1, 5. Those are 2 points on this line. So let's go plot them. 0 in the x direction, 3 in the y direction. That's right here. 0, 3. There's 0, 3. And then we need to go plot 1, 5. 1, 5. So our line, that's probably going to mess with it. Go right over here. 1, 5. So our line is going to be, now that we have 2 points, we know what our line looks like. It looks like, now, unfortunately, my coordinate system is not perfect, but close enough. Our line is going to look something like that. All these points are going to be the points that satisfy this.
Right.
So another point, if we were looking at this, that we see it's eventually going to get, is 2, 7. Let's check that. If I plug in 2 for x, what do I get? We get 2y minus 8 is equal to 6, right? That's plugging in 2 for x. Add 8 to both sides, we get 2y is equal to 14. Y equals 7. Whoa, magic. How did I know? Because there's a point on the line. All the points on the line satisfy that equation. Okay. So now, let's talk about the slope of this line. We know 2 points on the line, we can figure out the slope. Pick 2 points, I don't care which 2. Which 2 should we use? Bottom 2, bottom and top, top 2, top 2. Okay. Which one should we call x1? We'll call this one right here our x2, y2. And we'll call this one right here our x1, y1. Doesn't matter which 2 points we use. Pick 2 points on the line. And now we're going to calculate our slope. We know that our slope, typically we use an m for our slope. Our slope is equal to y2 minus y1. y2 is 5. Minus y1 is 7. So it's 5 minus 7 all over x2 minus x1. x2 is 1 minus 2, which is equal to 5 minus 7 is?
3. Negative 3.
-2.
Sorry, negative.
Negative 2. And 1 minus 2 is? Negative 1. Or negative 2 divided by negative 1 is just? Positive 2.
Yes.
A negative divided by a negative is positive. So the slope is 2. For every 1 unit we go over, we go up 2. Or 2 over 1 if you want to leave it that way. Our rise over our run. If you go over 1, you go up 2. That's our slope. That's exactly what it is. We go over 1, up 2. We get this point. That's how I need to pick this point. Go over 1, up 2. We get that point. Make sense?
Yeah.
That's calculating our slope. Okay. So now that we have our slope, sometimes we only know, notice that there's 2 pieces of information that I could give you. How's the best way to say this? Let's keep this. So our slope is equal to y2 minus y1 over x2 minus x1. Now sometimes, instead of knowing 2 points that the line goes through, we only know that it goes through some single point, x1, y1. x1, comma, y1. So we know it goes through that point. And we want to find any other point, x sub y. X, comma, y. So now x1, y1, that's a fixed point that we know of. And now we want to find any other arbitrary point on this line, x, comma, y. The slope is still y minus y1 over x minus x1. For any point x sub y, this still gives you the slope. You with me? Now, I'm going to make this an equation that's a little bit nicer to work with. I'm going to multiply both sides of this equation by x minus x1. And multiply this side by x minus x1. And what do we get? What happens over here?
Those cancel out.
These cancel out. Leaving us with, I'm going to flip the order I write these in.
Y equals y1 equals m times.
Y minus y1 is equal to m times x minus x1. Okay?
Yeah.
This is called the point-slope form of a line. So there's 2 ways you can figure out a line. I can know 2 points that the line goes through, or you can just tell me 1 point that the line goes through, and then tell me the slope it should have. And that also tells me the line. So if I know that my line should go through the point, let's make up one really quick. Give me a point.
2.6.
2 comma 6.
Yes.
So we have the point 2 comma 6. So that's my x1, y1 are 2 and 6. All right, what slope should we have?
A slope of 3.
A slope of 3. So she's telling me, I want you to construct a line. It goes through 2, 1, 2, 3, 4, 5, 6. It goes through 2, 6, and it has a slope of 3. There is only one line that goes through that point and has a slope of 3. Any other line I draw through that point would have a slightly different slope. If I give it exactly a slope of 3, it's going to be the one and only one line that we're talking about. Okay? So let's come up with this line. Or let's come up with the equation for this line. What's the equation for the line? Right here. It's going to be y minus, what's y1? 6 is equal to m, what's m? 3 times x minus x1. X minus, what's x1? 2. And here's the equation of our line. You can distribute it out, work it out however you want, but here's the equation of the line. Write it in whatever form you want. And now you can plug in whatever other point you want to know. Let's say I want to know, let's plot some points. I want to know what happens when x is 0. So if x is 0, 0 minus 2 is? 0 minus 2 is? 0 minus 2 is?
0.
If you have $0 and then you owe me $2, how much money do you have? Negative $2. Okay, so negative 2 times 3 is? Negative 2 times 3 is? negative 6. So we have y minus 6 is equal to negative 6. And then add 6 to both sides. And it's y equals 0. So it turns out this line is going to go through 0, 0. That's one way you could have done it. Or you could have said, oh, she told me it has a slope of 3. So that means if I go over 1, I have to go up 1, right? So over 1, up 1. There's another point on the line. But 3 over 1 is also the same thing as negative 3 over negative 1. You see how those are the same thing? So I could also go down 1, or I could also go back 1 and down 1. And that's still slope of 3. So I go back 1 and down 3. 1, 2, 3. I can go down 1, or back 1 and down 3. And that gives me that point. Right? Now sometimes the special point that we care about, rather than being given an arbitrary point x1, y1, they instead give us as a point we know where it goes through the y-axis. So, new game. I tell you that a line has a slope of m, whatever m is. You know the slope. And I tell you it goes through the point 0, comma, b. So what's b? It's wherever it crosses the y-axis. That's the special point I tell you. I tell you, draw the line that goes through this point with this as its slope. So it's up here at b, whatever b is. It goes through this point. And then it has a slope of m, whatever m is. Something like that. Let's plug that point in to this equation. You with me?
Yeah.
So we have y minus, what's y1? If our special point is 0, comma b, it's b. So we have y minus b is equal to m times x minus x1. What is x1? 0. What's x minus 0? X. So it's just x. So mx. Or you can solve for y, and you get y is equal to mx plus b. This is called the slope-intercept form. You know where it crosses the y-axis, that's your b, and you know the slope of the line, that's your m. This is how people typically write the equations of lines nowadays. They use the the slope-intercept form of the line. Okay? So we talked about the point-slope form. That's right here. This is a point-slope form. We talked about the slope-intercept form. That's right here. We talked about how to plot points and lines. That's what we were initially doing when you create these little t-charts. You pick some x values, pick some y's, plot some points so you see what the line's doing, then just draw it in. And we talked about how you calculate the slope. It's y2 minus y1 over x2 minus x1. You always need 2 points to get slope. Right? Yes. Okay. Last thing we need to talk about is parallel and perpendicular lines. What does it mean for two lines to be parallel? If I have a line here and this line is parallel to it, what does that mean?
They'll never have a point that will...
They'll never intersect. What does it mean in terms of things we talked about today? Which one's steeper? If one's steeper than the other, they're eventually going to intersect. So they have the same steepness. Otherwise, they'd intersect. So parallel lines have the same slope. Parallel lines have the same slope. Just different heights. Different heights up in the air, same slope. Parallel lines. So sometimes you'll be told to do a problem along the lines of, they'll say something like, find a line parallel to y equals 2x. So find the line that's parallel to y equals 2x, but I want it to go through the point 1, 7. So find the line that's parallel to this that goes through the point 1, 7. Okay, that's our job. So 1, 7, where's that? 1, 1, 2, 3, 4, 5, 6, 7. So it goes through this point, and it's parallel to that line. So what is the slope of the line here? What's the slope of this line right here?
Whatever x is.
This is y equals 2x plus 0. What's the m? 2. What's the b? 0. So the equation of this line right here, if we were to draw it out, is right here. It has a slope of 2, and it looks like this, roughly. That's this line. Now, I'm trying to come up with a line that goes through this point and is parallel to this line. So what does the slope of my line have to be? Which is, what's the slope of this line? 2. Y equals mx plus b. And m's the slope. If you rewrite your equations this way, then you write it in the slope-intercept form. This is a line with a slope of 2 that goes through the point 0, 0. Goes through the origin. Right?
Yeah.
So what's the slope of this line? 2. So the slope of the line through this point has to have a slope of 2. So I'm looking for a line with a slope of 2 that goes through the point 1, 7. So I know the slope I want, and I know the point I want, and I'm looking for the equation of the line. So we're going to use the point-slope form. I know a point, and I know the slope. This will give me the equation. So it's y minus y1. What's my y1?
7.
7. Y minus y1 is equal to m. What's my m?
2.
2 times x minus, what's x1?
1.
1. So we get y minus 7 is equal to 2x minus 2 plus 7 to both sides. We get y is equal to 2x plus 5. So this line is going to be the one it goes through at 5. 1, 2, 3, 4, 5. And it's going to have a slope of 2. So it goes over 1, up 2. Yep, hits that point. Over 1, up 2. Right there. And if we draw it in, it would look like that. So parallel lines have the same slope. They're the easy ones. Perpendicular lines, on the other hand, are not so easy. So now let's look for a line perpendicular to this line. And we'll say it also goes through the origin. So we'll say they intersect at the origin. We're looking for the perpendicular line. What is the perpendicular line?
Perpendicular is where they meet. They have one point where it will. I think I'm right.
Parallel lines, perpendicular lines.
Oh, yeah. Okay, so they have one point where they will meet. The lines will meet at one point.
That's true for any lines that intersect. These are not perpendicular lines. If I draw that line and that line, those are not perpendicular to each other. Perpendicular means that they intersect at right angles.
Oh. Okay.
Intersect at right angles. Parallel, perpendicular. Okay, so we need to find the line. We want to also go through the origin. We'll pick the one that goes through the origin. But now it's perpendicular to this. So let's just try to eyeball this first and get a rough idea for what it should look like. So whatever we're talking about, it should look roughly like this thing. Perpendicular. Right? Okay, so I give us some rough idea to guide our intuition. Now remember, this right here is the line y equals 2x. What's the slope of this line? 2. What then does it look like the slope of this line is going to be? Is this one steeper or shallower? Is it easier for you to walk up this or walk up this? It's easier to walk up this one. If it's easier, it's shallower. It's not as steep. It has less slope. This line has more slope. This line has less slope. Less slope. So it would be the reciprocal. Yes. Perfect. So if we were to write this out, this is 2 over 1x, if we want to be a little bit pedantic there. And so the slope of this line is 1/2 x. This is going to be y equals 1/2 x. If we make this, imagine those are hooked, so I'll just use my arms. As I make this one, my right hand, notice that as I make my right hand steeper, I make my left hand shallower. Right? So if this had a slope of 5, this would only have a slope of 1/5. On the other hand, if this had a slope of 1/2, this would have a slope of 2. If I take my right hand and I tip it so much that its slope is 1/2, notice that my left hand is now really steep. So they're reciprocals of each other. Now almost. Notice how as I go along this line, I'm getting higher and higher and higher. Right? But this line is pointing downwards. Yeah, this we're going down, this we're going up. This is a positive slope, this is a negative slope. So it's the negative reciprocal. This is how you find the perpendicular. So if a line is parallel to another line, that means they have the same slope. If a line is perpendicular to each other, if two lines are perpendicular to each other, then that means their slopes are negative reciprocals of each other. Times this by -1 and flip the fraction over, you get this. Times this by -1, flip the fraction over, you get this. Good?
Yeah.
All right. And then finally, two special cases. Two special cases, which are the lines x just equals a number or y just equals a number. We really like these equations. They're the easiest. Sometimes we call them constant lines. So let's look at the function x equals a. And let's create our table here. All right. So if x equals a, the only value I can plug in for a, or for x, is a, right?
Yeah.
So if x is a, then y can y be 0?
No.
Why not? Y can be 0. If x is a, y can be 72. If x is a, y can be -2/3. If x is a, y can be, put any number you want here. What are all those points? If this is a on the x-axis, maybe shift it over here a little bit. If this is a on the x-axis, all the points where x is equal to a are all these points. These are all the points that have x coordinate a. So x equals a, that's all the coordinates with a as their x coordinate. That's it. So that's just a vertical line straight up and down. Similarly, if I would have told you, what about when y equals some number a? A vertical line at a. So if it's y equals 8, then that's a vertical line at 1, 2, 3, 4, 5, 6, 7, 8. That's just that line. Oops, missed, but you get the point. Well, these two lines happen to intersect, but they're two separate lines. I just drew two lines. And yes, they would intersect at the point a, 8. That's just one point on both those lines. Okay, so now we'll just pull up what the author has, go over his example problems, and get comfortable solving a bunch of these. But big picture, that's it. That's the whole chapter. Not bad, right? Easy as pie? Ready to solve it? Well, let's get to the point where it is easy as pie. Ew, I unplugged this. Did not notice that. It's cold? Say that again? Sure. All right. Pull that up. Get our book here. Okay. Let's get some scribble space. All right, so our first problem is to plot all these points. Let's see, how far does it go? No further than 4. So we'll do that. We'll do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, let's plot these points. So the point A is a point 3, 2. Where's that going to be? 3 to the right, 2 up. Right there. There's A. Now it says plot this point, -2, 1. That's -2 in the x direction, 1 down. There's B. C, that's 3 units to the right, 4 units down. There's C.
Wouldn't B be 1 up, top down?
Thank you. Good. All right. D is -2, and then -3. There's D. E is -3, 0. So it's right on there. So that one is E. F is 0, 2. 0 in the x direction, 2 up. And then finally, G is the origin. All right, there we go. Plotting points. Doesn't get any easier than that. Okay. Looks like we got roughly right. Okay, next. Plotting these things. So we got the equation of some line here, y equals 2x minus 3. And we want to plot that thing. So we're just going to pick some values of x to plug in. It doesn't matter what values you choose. Pick any values you want. Just enough to get a feel for the line. The author happens to choose -1, 0, and 1. Okay, if I plug -1 in for x, what do we get? What is y if I plug in -1 for x? What's 2 times -1? What's 2 times -1? -2. Subtract 3. -5. Okay, there it is. -5. Let's plug 0 in for x. 2 times 0 is? 0. Minus 3 is? -3. All right, we're waking up. 2 times 1 is?
2.
Minus 3 is? -1. Perfect. So we got 3 points. We can plot the line real quick that goes through those 3 points. So it's more negative than it's positive. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. All right, whatever. So -1, -5 is on there. So -1 and then down 5. 1, 2, 3, 4, 5. There's a point on the line. 0, -3. That's 0, 1, 2, 3. And then 1, -1. That's right there. And so our line is going to be, see if I can do it. There's our line. So plot enough points that you can figure out where the line goes, and then draw the line through it, just like the author does there. So that's what you're going to be required to do when it says plot the line. It's going to give you some equation. Just plug in some points until you can see what the line's obviously doing, then draw the line in. That's it. Okay. I don't think we need to do a lot of those. Those ones are pretty straightforward, right? No? Yes?
Yes.
All right. Next one. Slope. Slope is rise over run. Here's a random line. And we're trying to figure out its slope. We need to figure out its rise over its run between 2 points. The author picks this point and this point. How much does the line go up from here to here? What's the change in height? It goes down 1, 2, 3, 4 units. So our slope, m, is equal to -4. That's our change in height. Over what was our run? 6. So it's -4 over 6. Or in other words, it's -2/3. That is the slope of that line. For every 2 units you go over, you go down 3. Oh, other way. For every 3 units you go over, you go down 2. So if I go over 3 more, 1, 2, 3, I go down 2. Over 3, down 2. Or you can read it in reverse. You can think about this as -2 over 3, or you can think about it as 2 over -3. This means go up 2 if you go back 3. So if I start right here, go back 3, 1, 2, 3, then go up 2, 1, 2. Back 3, 1, 2, 3, up 2, 1, 2. And it works. Okay. So there's the slope of that line. Gives you another example of a line. We go up 6 over 3. What's our slope? We go up 6, we go over 3. 6 over 3 is? 2. You get that on your drill sheet, right? 6 divided by 3? Okay. And then he says, what's the slope of this line? Let's see. So we got a point here. The coordinate of this point is -2, 2, right? 2 to the left, 2 up. Let's look at the coordinate of this point. This is a point 1, 2. So how do we calculate rise over run? Remember our formula. Our formula is m is equal to y2 minus y1 all over x2 minus x1, right? Let's see. What's y2? Pick one of them to be y2, doesn't matter. So we call this the point x2, y2, or this the point x2, y2?
The other one.
We're going to call this one x2, y2? Okay, so here's our point x2, y2. And here's our point x1, y1. So we're going to do y2 minus y1. What's y2? Minus what's y1? 2. All over what's x2?
-2.
That's a comma. -2 minus 1. Okay, let's see what we get. 2 minus 2 is 0. -2 minus 1 is -3. So we get -0/3, which is the same thing as 0 divided by 3. I need to start making these drill sheets that have zeros in them. 0 times anything is
0.
0 divided by anything is
0.
wonderful. So the slope of this line is 0. It has no slope. Who would have thought?
Is it E?
You would have. That's good.
The line is just straight across.
Yeah. That's exactly why. A line with no slope. It's flat.
You don't have to solve for it in order to find that. You could just.
Well, notice that what you know to be true and the math always agree with each other. And so if the math is screaming it's 0, then it's 0. Or if you see it's 0 here, then the math better tell you it's 0. Math can't lie to you. It's impossible. So you're right. We could have just looked at this and said, obviously the slope is 0. Or you could have calculated it and still got, obviously the slope is 0. Because 0 divided by anything is 0. So obviously, right? All right, now let's try this one. This point. What's its coordinates?
3.
Is that too hard for you guys to see?
2 and 3, 2.
3 comma 2 is what that is. This one is 3 comma minus 2.
Yeah.
Can't believe you let me bait me into that. Tongue twister. Okay. Don't die. Okay. So here's our 2 points. Which one should we call the x2, y2? Which one should we call the x1, y1? So we want this one to be x2, y2. And we have this one be the x1, y1. And then just looking at it, what should the slope obviously be? 0. This is no slope. How do you get steeper than this? That's as steep as steep gets. So it definitely doesn't have no slope. That doesn't make sense.
It has the slope of the x, so it's 3.
Oh.
So if I move the line over here, so instead it was going through the point 2, then its slope would only be 2.
There is
No.
And if I put it through the origin, then its slope is 0. Okay, so that doesn't make sense.
Let's just do undefined.
Should we just plug it in and see what happens? All right, let's plug it in and see what happens. So we're going to do y2 minus y1. So what's y2?
3.
3. Minus what's y1? So minus -2. Don't confuse yourself when you do that. It's always the coordinate minus the coordinate. So don't accidentally do just -2 there.
Minus 3 for x.
And then we get 3 minus 3 here. Okay, so what's 3 minus -2? 5. Thank you. 5. What's 3 minus 3?
0.
0. And anything divided by 0 is 0, right? Undefined. Don't fall for that. It's undefined. You can't divide by 0. A number divided by 0 is not 0. It's undefined. And the way we say this in calculus is that slope tends towards infinity. Or some people might say, oh, that has an infinite slope. But undefined is a perfectly acceptable answer. The slope is undefined. So, vertical line has no slope. A vertical line slope is undefined. That's where we say that. A horizontal line has no slope. Its slope is 0. Okay. So, The two gotchas there we covered. That's good. He's deriving the formula. Just plugging in the slope between 2 points. I don't think we need to do much more of that. We can do this one. Find the value of y between the points 2y and 5 minus 1 with slope 3. Or with slope minus 3. Okay. So here's a cool one. You don't have to talk. All right.
Okay.
Focus, focus. It's a trick problem. Okay. So we're trying to find y, right?
Yes, yeah.
We have 2 points here. We have a point 2 comma y. I don't know what the y is. And we have a 5 minus 1. But we know that the slope between those 2 points is negative 3. So let's go back to our formula. I know always and forever y2. Oh, we have it right here. y2 minus y1 is equal to x2, or over x2 minus x1 is equal to our slope, right? Now here's my 2 points. It doesn't matter which one I call the y1, y2, the y1, x1, and the y2, x2, and the y1, x1. Doesn't matter which one we call that. So I'm going to call this one my x2, y2, and they call this one my x1, y1. You with me? So I know that this one's y. What's the y coordinate of this point? It's just y. Minus this one's y. What's this one's y? Negative 1. Over, what's this one's x? Is equal to the slope. And our slope is negative 3. So here's your equation, and you're just solving for y. So this is actually real easy. So let's work with it. What's y minus negative 1? Y minus, what? If we subtract the negative 1 from y, that's the same thing as adding
A 1.
adding 1. So that becomes y plus 1. Okay. Y minus negative 1 is y plus 1. When you subtract the negative, that's the same as adding a positive. Negative 3. And this is equal to negative 3. Okay. Now I hate having that denominator there. It's making my life miserable. What should we do? How do I cancel out that negative 3 over here? No. Okay. What's the reciprocal of negative 1/3?
Negative 1/3. It's 3.
Negative 3. We want to multiply both sides by negative 3. Come on, people. We want to multiply by whatever's in the denominator there so they cancel out. You kept saying add. I heard you say add. I was listening for multiply. I heard lots of divides, lots of adds. Maybe you did when you all mumble, multiply. Okay, so we have the negative 3 and the negative 3. Negative 3 and negative 3 cancel out, leaving?
0.
I'm going to kill you. Negative 3 and negative 3. 1! 1! Come on. We made this breakthrough last week. Let's not regress. A number divided by itself is 1. Negative 3 over negative 3 is 1. X over x is 1. A over a is 1. Anything over that same thing is 1. Okay. Now 1 times y plus 1 is just y plus 1. Thank you. All right. Negative 3 times negative 3 is 9. All right. So now what's y?
8.
Sure.
Y is 8.
So y is equal to 8. Wonderful. So we found the coordinate of that point. It's 2, 8. Great, that's cool. Agreed. That was a lot of work. I'm not so sure. We started with that. We subtracted negative 1, multiplied by negative 3, and then subtracted 1. 3 pieces of arithmetic. I think we can handle that. Okay, let's try another one just like it, and this time, hopefully, we don't get so stumped. Okay. So this time we have 2 points, negative 3 comma 2 and x comma 6. And our slope is 2/5. So our equation is always and forever, y2 minus y1 over x2 minus x1 is equal to our slope m. Okay, now it doesn't matter which one we call which. So which one should be our x2, y2, which one our x1, y1?
Did the last one x2.
Okay, so this will be our 2's, this will be our 1's. Okay, so we have y2 minus y1 over x2 minus, okay, and this is all going to be equal to 2/5. Okay, now 6 minus 2 is?
6 minus 2 is 4.
Good. X minus negative 3 is?
3. X plus 4.
X plus 3. Okay, and that is equal to 2/5. All right, now I have that x plus 3 in the denominator. Isn't that annoying? What can I do to get it out of the denominator?
No. Why did you get by 3?
Not by 3, not by 4. How do I get x plus 3 out of the denominator? I multiply both sides by x plus 3. Whatever is in the denominator, just multiply both sides by it. Right? So we're going to multiply this side by x plus 3. And we're going to multiply this side by x plus 3. Okay. X plus 3 over x plus 3 is? 1. 1 times 4 is? 4. We're still there. Good. And then we have x plus 3 is the same thing as x plus 3 over 1. 2 times x plus 3 gives me?
2x plus 6.
Good. All over 5 times 1 is?
5.
Okay. Again, I hate having that 5 in the denominator. What do I do?
Both sides by 5.
There it is. Yes.
Because 5 times 1 is 5. You're just multiplying the top and the bottom.
I start with this, and I multiply both sides by x plus 3.
No, how did you get 5 on the top one?
Huh?
You're saying down here?
No, on the top. Is that 2/5? How did you get to 5?
2/5 was a slope that we had up here.
Okay.
Are you good? Here's what we started with. Do you understand where all these numbers came from?
Yes. Right.
I know that. Oh, yeah.
Unless you have glasses on.
All right.
It's nothing.
Okay. So that's how we got to here. Here to here, we simplified that to be x plus 3. Multiply both sides by x plus 3. Those x plus 3's cancel out, just leaving the 4. 2x plus 6 all over 5. Now we're multiplying both sides by 5. Good. So it's 20 equals 2x plus 6. Now what do we do?
Minus
6.
20 minus 6 is?
14.
14 is equal to 2x, or in other words, x is equal to 7. Good. That wasn't as bad. X equals 7. And there we are. We're done with the whole section. Can't get any easier than that. Okay. Now we already talked about this equation, y equals mx plus b. What is m? What is b? Your y-intercept. It's where it crosses the y-axis. So, if I were to give you an equation, just off the top of my head, if I told you y is equal to negative 17, or negative 71 over 32x plus 91, what's the slope of that line?
Negative
Negative
71
71 over 32.
The slope is negative 71 over 32. Where does it intersect the y-axis? At 91. Good. That's the value of writing it this way. Gives you a lot of information real quick. Okay. So, mx plus b. That's what it is. So now, let's see. Get an example problem here. Oh, they want you to find the equation when they give you a picture. So here they give you the picture and they say, let's find the equation of the line, of this line, right? So we're looking for our m and our b. We need our slope and our y-intercept. So we're going to write it in the form y equals mx plus b. So it's going to be y equals, let's see, what's our slope? If I go over 1, 2, 3, I go down 2. So over 3, down 2. Or our rise is minus 2, and our run is 3. So minus 2/3 is our m. We still have x plus, what's b? Where do we cross the y-axis? Try again.
2, 3.
3.
Sorry, my glasses.
Yeah,
It's just blurry.
it's dim. All right, but you understood how to do it. Okay, so going from a picture to the equation, stupid easy, right? No point even doing it. No point even giving you a test problem on it. All right, what's this one supposed to be? Example that, graph this. Okay, so now we're going the opposite way. So this time, we start out with y is equal to, what was our equation? 1/2 x minus 4, right? So first off, where do we cross the y-axis?
-4.
-4. 1, 2, 3, 4, down here. Yeah. Then our slope is 1/2. So if you go up 1, you go over 2. If you go up 1, you go over 2. If you go up 1, you go over 2. And our line looks something like that. And we got basically the same line. So that's how you graph the line. Pretty simple. All right, let's do this one. How would we graph a line like this? It gave us 3x plus 4y equals 12. Isn't that obnoxious?
3 over to the other 3x.
Yeah, let's just solve for y. Pretty easy. So if we're going to get y by itself, first thing we need to do is subtract 3x from both sides. So we get 4y, sorry, yy, the greatest question ever asked. 4y is equal to negative 3x plus 12, because I moved the 3x to the other side, right? Subtract 3x from both sides. Okay, now what?
5, 4.
Divide everything by 4. So 4y divided by 4 is? Y. Good job. Negative 3x divided by 4 is? Negative 3/4 x. 12 divided by 4 is? 3. So we just divide everything by 4. Okay, what's our slope? Negative 3/4. What's our y-intercept? 3. So let's graph this thing. Okay, so we know we go through the point 0, 3. Our y-intercept is 3, so we have that. Now, our slope is negative 3/4. So we can go over 4 and down 3, or we can go back 4 and up 3. We can either think about this as negative 3 over 4, or we can think about it as 3 over negative 4. Doesn't matter which way. I'm going to think about it this way. I'm going to think about if I go over 4, I go down 3. So I'm going to go over 4, 1, 2, 3, 4, and down 3, puts us right there. Good?
Yeah.
Okay. And ta-da, who would have thunk? All right, x equals negative 4. That's just a vertical line at negative 4. We already talked about how to do those. What? I thought you were saying something about it. Guess not. All right. And now, going back to our point slope formula. So our point slope formula was y minus y1 is equal to m times x minus x1. Here's a formula we use when we know the slope and we know a point. Right?
Yes.
Okay. So let's do it. So we have an equation that goes through 3, negative 4 and a slope of 3/5. And we're looking for the equation of the line. So it goes through 3, negative 4 and has a slope of 3/5. So we're going to have y minus, what's y1? Negative 4 is equal to, what's my m? 3/5.
Times
All times x minus, what's x1? 3. All right. So now, this is y minus negative 4 is? It's plus adding it. So it's plus 4. That's what we're after. 3/5 times x is 3/5 x. 3/5 x. 3/5 times negative 3 is? It's not that bad. Look, negative 3 is the same thing as negative 3 over 1. Okay. 3 times negative 3 is?
negative 9.
Negative 9. 5 times 1 is? 5. Whew. Yeah, not that bad. Okay, now what?
Now you're going to subtract 4 from both sides.
Subtract 4 from both sides. Sure, why not? Okay, so then we get 4 minus 4 is?
0.
Close. 4 minus 4 is 0. Y plus 0 is? Y. So we're left with just y. Is equal to 3/5 x. And now we have negative 9/5 minus 4. So that's minus 9/5. And we're going to subtract from that 4. Or 4 over 1. Okay, so to combine these two together, we need to find a common divisor. What's the common divisor between 5 and 5? Let's kind of do this as a side problem, just decide. So we're looking at negative 9/5 minus 4 over 1. All right, common divisor between 5 and 1 is 5. So I need to multiply this number top and bottom by 5. So this multiply top and bottom by 5.
So 20 over.
What is 5 divided by 5? 1. So I just took this number and multiplied it by 1, which doesn't change the number. That's why this is legal. I haven't changed the number. And so we're left with negative 9 over 5 minus 4 times 5 is 20 over 5, which is equal to,
11.
try again,
Negative 11.
try again, negative 9 minus 20. Negative 29.
I'm sorry.
Negative 29 over 5. Okay, so when it's all said and done, we get y is equal to 3/5 x minus 29/5. Sorry, that's a 5. That's an awful 5. Not much better. I'm not sure if that's the form they wrote it in. We'll see.
They just simplify it.
Oh, they just leave it like that. Which is how we had it right here. Oh, they didn't even multiply it out.
They didn't do anything.
Yeah, they did nothing with
They
it.
just added their things.
All right, yeah, so we sure worked you guys for nothing. Gotcha. Can't believe you fell for it. Okay.
So that's all you have to do with
I guess that's all you have to do. Not going to argue with the author. Okay. Not sure if we need to see more of these. Let's do one like this, though. One where they just give us 2 points. All right, so we have this equation. When we have a point and slope, they didn't give us a point and slope. They gave us 2 points.
You gotta put points into your slope form.
Right, we just got to calculate the slope first, and then we can do it. So our slope, m, is equal to, which one should we call y1, x1, and y2, x2?
Do y1 for the first one.
So those will be our 1s, those will be our 2s. Okay, so our slope is y2 minus y1.
Or subtract negative.
Y.
Negative.
You're going to mix that up a lot. We're doing the y's, which are the right-hand ones. So negative 3 minus 5. y2 minus y1 all over.
4 minus
Negative 2.
Wonderful. Negative 3 minus 5 is?
8. Ew.
Negative 8.
Uh-huh.
Negative 3 minus 5. Come on, guys. Negative 8. 4 minus negative 2 is?
It's 2.
It's 6.
Subtracting a negative is the same thing as adding a positive. So it's 6. All right. Okay, now we can pull 2 out of the top and bottom.
So
We can
4
reduce
and
it.
3.
So negative 4 over 3. Okay, so there's our slope, negative 4/3. Right? So now we can write this as y minus, what was y1?
5.
5 is equal to our slope, which is negative 4/3, times x minus, what's x1? Negative 2. So that becomes plus 2. Don't get confused by that. Minus negative 2, plus 2. Okay. And we'll see if that's how the author wrote it. Y minus 5.
It's the same thing.
Except for us.
Is it not identical? What's the difference between that and that? Oh. So you guys are saying we missed something. Okay. All right, so we got that. Doing it with 2 different points, no point. I think you guys get it. So now we'll move on to parallel and perpendicular. All right. These lines are, and these lines are.
Perpendicular.
You got it. What more do we need? All right. So let's actually do some fun problems. Or you'll be finding equations of lines where it needs to be parallel to a given line or perpendicular to a given line. All right, so let's do the first one. Find the slope of a line parallel to this line. So here's some line. So we have 5y minus 2x equals 7. Okay, what's the slope of that line? I don't know. Let's solve for y and figure it out. So what do we do first?
Subtract. Add 2x to both sides.
Add 2x to both sides. Good. So we get 5y is equal to 2x minus 7. Now what?
Now you're going to divide 5.
Divide by 5. Divide everything by 5. Divide that by 5. Divide that by 5. Divide that by 5. Divide everything by 5. Okay. 5 over 5 is? 1 times y is? Y. Y is equal to 2/5 x minus 7/5. What's the slope? 2/5. The slope is 2/5. Saying the slope is 2/5 x doesn't make any sense. What do you mean it's 2/5 x? The slope of the line depends on my x coordinate. It's not a line anymore. That's something that's changing depending on your x coordinate. Okay, so our slope is 2/5. So any line in the universe parallel to this line must have a slope of 2/5. So this says find the slope of a line parallel to this line. What's our slope going to be? 2/5. Crazy. All right, what's next? Find the slope of a line perpendicular to this line. Okay. Remember, how do we get perpendicular? The negative reciprocal. Negative reciprocal of the slope. If I did a slope right here of 2, then the line perpendicular to it is going to have a slope of negative 1/2. So it's the negative reciprocal to get the perpendicular. They're negative reciprocals of each other. All right. So first off, let's look at this line. We have 3x minus 4y equals 2. Don't give up on me, guys. This is the last section. Subtract 3x from both sides? Okay. So subtract 3x from both sides, we get negative 4y is equal to negative 3x plus 2, right?
Yeah.
Now what? Divide everything by negative 4. Divide that by negative 4. Divide that by negative 4. Divide that by negative 4. All right. Negative 4 over negative 4 is? 1. 1 times y is? Y is equal to negative 3 over positive 3/4. Because a negative over a negative is positive. And then 2 divided by negative 4 is? Negative 2/4, or? If you have 2/4 of a pizza, how much pizza do you have? You have half the pizza. Good. All right. So here's the slope of this line. So if a line is perpendicular to it, what's its slope going to be? 4/3, almost. Negative 4/3. It's the negative reciprocal. So it's going to be all the lines y equals to negative 4/3 x plus b. Any line of this form is going to be perpendicular to this line. And there's an infinite number of perpendicular lines. Okay. So our solution, slope is negative 4/3. Yay. Okay. Find the equation of this line parallel to this one. I guess we can do a parallel one, and then we'll do one like this that's perpendicular, and we'll call it. Okay. So I'm given a point, and I'm looking for the line that goes through this point and is parallel to this line. In other words, I'm looking for the line that goes through this point and has the same slope as this line. So first, let's look at this line to figure out what our slope is going to be, and then we'll go back and figure out the equation of the line that goes through this point and has that slope. So we're using this to figure out our slope. So I have 2x minus 3y equals 6. What do we do first? Subtract 2x from both sides. We get negative 3y is equal to negative 2x plus 6. Good. Now what? Divide everything by negative 3. Divide u by negative 3. Divide u by negative 3. Divide u by negative 3.
Negative 3 divided by negative 2 is 1. Y.
Wonderful.
Equals
Negative 2 over negative 3 is
positive 2/3.
positive 2/3 x. 6 over negative 3 is
3. Negative 3.
a positive over a negative is going to be
Negative.
negative. And 6 over 3 is 2. 2. So we get plus 2, right? Plus 2, right?
Yes.
Yes?
Yes.
Wow.
Minus 2. I had such high hopes. Okay. So what is the slope of this line?
2/3.
2/3. So what are we looking for? We are looking for a line that goes through this point and has the same slope as this line. So we know that we want our slope m to be 2/3. Okay, so now we just got to find the equation of a line that goes through this point and has a slope of 2/3. So we're going to use the point slope form. The form that takes a point and a slope. The point slope form is, what is it?
Y
Y minus y1
equals m parentheses
x
x.
minus x1.
Excellent. Okay, so now let's plug it in. So y minus, what's our y1? Negative 5 is equal to m, oops, 2/3. Thank you. 2/3 x minus x1.
4.
So minus 4. Wonderful. Y minus negative 5 is? Y plus 5 is equal to, they probably just leave it like this, I don't know. 2/3 x minus 4. Y plus 5 is equal to 2/3 x minus 4. Okay, now let's do one more, except for this time perpendicular.
But we already have our slope.
So it says, find the equation of a line through this point, perpendicular to this line, and write it in the slope-intercept form. So we need to write this as y equals mx plus b. Okay, so that's everything it's telling us. So first off, if it's going to be perpendicular to this line, first off, what's the slope of this line?
Negative 3.
The slope of this line is negative 3/5. So our slope is going to be 5/3. The negative reciprocal of that. Flip the numbers over and then swap the signs.
Right.
So here's our slope. So the equation for our line has this as its slope, and it goes through this point. So right here, we have a point, we have the slope. So it's going to be y minus, what's y1? Negative 9 is equal to m x minus 6. And now it says write it in the slope-intercept form. Slope-intercept form means we need to get this as y equals mx plus b. In other words, solve for y. Get y by itself. Okay, so here we have
Y plus
y plus 9, good, is equal to 5/3 x minus, anyone able to do that in their heads? Impress me.
Would it be 30 over
30 over 3, which is?
10?
Look at that. Now, we're doing 5/3 times 6. Notice that 6, if you take 3 out of it, that leaves you with 2, crossing out with that. And so you get 5 times 2. But how you guys do it is fine. So minus 10.
Okay, now you want to subtract 9 from both sides.
Subtract 9 from both sides. And so we get y is equal to 5/3 x minus 19. And there we go. That is the slope-intercept form. Let's see if we got it right. Y equals 5/3 x minus 19. Wonderful. Okay. And so that is it. So that's it for the lecture. That's it for the chapter. That's the last chapter that will show up on your first test.
Yay. So excited for that test.
So am I. Stoked. Gotta go write it still, though. Any questions that you want to record on lecture before I turn it off? That's a lot of questions. But we have no time for them, so you can turn off the